Hey guys, so I'm going to be showing you how to do a second order equation. It's going to wind up being a little different than the way it's been presented in lecture and in the textbook, but I find that this is actually a much more straightforward way of approaching the problem. So we've got our initial equation here. Let me just write down our initial conditions. So y of 0 is equal to 2, and we have y prime of 0 is equal to negative 1. So first and foremost, let's determine our characteristic equation. Now our characteristic equation is determined by our initial function. So if we have some a y prime, double prime plus some b y prime plus some c y is equal to 0, that means that our characteristic equation is going to look like a r squared plus b r plus c is equal to 0. So in our case, what this is r squared plus 2r plus c is equal to 0. And you can put that in your calculator to find that r is equal to negative 1. So we only have one root here. It's not a complex root, and we don't have two. So we need to make sure we use the formula for repeated roots. So the characteristic equation of that is actually equal to y e to the r x c1 plus x e to the r x c2. And in our case, that just becomes e negative x c1 plus x, I should have an r there, x c2 e negative x. And you'll notice that I didn't put a negative sign right here, even though r is obviously negative 1, because c2 is an arbitrary constant. So it doesn't really matter. Now we just decided, well, not decided, but it was given that our initial conditions are y of 0 is equal to 2. So let's go ahead and solve for that. So y 0 is equal to 2 is equal to e to the 0 c1 plus 0 c2 e to the 0, which is equal to just c1. So therefore, c1 is equal to 2. Now, we can't solve our initial condition y at 0. We can't solve for c2 with that, so what we're going to do is we're going to take the derivative. So pay close attention here while we take the derivative, because those negative signs can get a little tricky. So the derivative of e to the negative x times some constant is just negative e to the negative x times that same constant again. But then we're dealing with a chain rule. So let's just take derivative of the first times the second. So we've got the derivative of the first, so that x times the second, so 1 times this function. And then we're going to take x times the derivative of the second function, which is just negative x c2 e to the negative x equals y prime. So what we're going to do is we're going to plug in the initial condition we have. So y prime of 0 is equal to negative 1. Y prime of 0 is equal to negative 1 is equal to negative e to the 0 times 2 plus c2 e to the 0 minus 0 c2 e to the 0. So obviously we can just disregard this term. We can just disregard that term and we'll simplify. So negative 2 plus c2 is equal to negative 1. So therefore c2 is equal to 0. Sorry, it's not equal to 0, it's equal to 1. So we're not quite done, even though we've figured out both our coefficients. So we're just going to write out the function. Y is equal to e to the negative x 2 plus x e to the negative x. And that's your final answer there. It's a little different than how it's taught in the textbook. The textbook will also give you two y expressions and ask you to verify, but not always. And again, it's not really needed to solve this question. So I'm just going to go through this one more time with a different colored marker because, like I said, it's a little different than the way it's approached in the textbook and in class. So we have here the second order equation, and you'll note that the a's, a coefficient, and the b all give you the characteristic equation. So that right there. So once you solve the r's in that characteristic equation, you'll know which formula to use. In this case, we're using the repeated roots. I'll be making a video on what to do with complex roots or just regular roots as well. So this is what it is for repeated root. And then you can look through there. And once you get that equation solved, you can plug in your r value and then take your initial conditions to solve for your C1 and your C2. Now hopefully it should be set up in a way you'll be given this y of 0 so that part of the equation just cancels itself out and you don't need to take too many steps to simplify. Otherwise you'll have to divide one equation by the other, and that can be tricky. As always, if you have any questions, feel free to leave them in the comments or message me directly. Other than that, thank you very much, and I'll see you on the next video.